I am co-founder of a company called Launch Scout in Cincinnati, Ohio. We do web and mobile custom app development. And yeah, that's me. So what are we going to be talking about today? I'm going to start with introducing Elixir and OTP briefly for people who aren't familiar with it. I'm then going to go into Wasmex, which is the wrapper library that lets Elixir talk to WebAssembly and WebAssembly Components. And then I'm going to spend a good portion of the time going through some demos. And finally, towards the end, I'll talk about sort of future directions, where the Wasmex project is going. All right, so I'm going to dive right in. So how many people are already writing Elixir, or at least have done a little bit or familiar with it? OK, so just a few people. Cool. So for those who haven't seen Elixir before, I think it's a really great language. It's kind of my favorite language for writing code. It is a functional language that runs on the Beam virtual machine, which is from Erlang. So Elixir kind of sits on top of Erlang. It's interesting. It's a functional language. All the data structures are immutable. It's a dynamically typed language, although there is a gradual type system that is being added to the language right now, and will be, it's underway and will be finished here in the next year or so. It's got a really easy to grok syntax. If you've done Erlang, the syntax can be a little bit intimidating, and Elixir has a syntax that's kind of closely modeled on Ruby. It was created by a guy named Jose Valim, who was originally from Brazil. It's now in Poland, and he was very active in the Ruby community before he created Elixir. So what's so great about the Beam virtual machine that underpins Elixir and Erlang? It's actually quite old. Elixir as a language is relatively recent, but Erlang's surprisingly old. It was started by Ericsson Telecommunications back in the 80s, and it was originally designed to run on telecommunications equipment, phone switches, that kind of thing. And so they've had decades to kind of think about how to build systems to run in those kinds of environments. And if you think about like what kind of characteristics you need to run on a phone switch, obviously you have to have a high degree of concurrency, and you can never, ever go down for any reason. It's not like you can say like, hey, sorry, we're upgrading, no phone calls between 3 and 5 a.m. on Sunday. That's not a thing you can do. It has to be up all the time. And it turns out these same characteristics are pretty awesome for building modern web applications too. So the thing that makes it go is really the concept of processes that Erlang adopts and the Beam adopts. And when we say processes in Erlang, we're not talking about operating system processes. They are like an order of magnitude at least smaller than an operating system processes. They come at like 2K. They have their own isolated memory, and the only way that processes can communicate with one another is through message passing. That means there is no shared mutable state at all. And because of that, it eliminates a whole class of problems that you usually have to deal with when you're talking about like concurrency and async. Because they are so small, it's been demonstrated that you can create millions of processes on a single machine and everything just hums along. And the most awesome thing, you have concurrency without any locks or mutexes or any of that jazz, which is pretty awesome. The other thing that processes can do and the Erlang OTP platform provides is supervision. So processes, you basically have worker processes, and you have other processes called supervisors that watch those processes. Supervisors themselves can be supervised by other supervisors, and so you have what looks like a tree, and they call that a supervision tree. And configurably, as part of the platform itself, when a worker crashes, the supervisor can do different things. It can restart just it. It can restart all of the children processes that it supervises, or it can just like give up and die and let its presumably supervisor do whatever it wants to, or it can say like, sorry, we're done, and shut down everything. And so because of this notion of supervision, the kind of model for programming in the OT platform kind of embraces this idea of let it crash, which is that rather than handle every possible failure scenario, we're going to stick to the happy path as much as is reasonable and let the supervisors deal with things that go wrong. So it's considered fairly normal to have a process crash in exceptional conditions. And as a result, like the practicality of it is it's really easy to accidentally create highly resilient systems. We've had some that we created as little demo apps that are dependent on external services that go up and down, and the thing will just like hum along for years, even in between things going up and down, because everything just restarts and it's great. So let's see what this looks like in practice. Here's a little bit of Elixir code. I'm not going to walk through all of it, but what this is it's a stateful stack worker process in Elixir. And the way that state works in Elixir, you have process functions that you call that in general, they will take a message and a current state and return a new state. And in this case, we have an init function that just sets up the initial state, which we decide is an empty list here. We have a handle call function that handles the pop message and gets the current state, which is the stack itself. And it's just basically going to split the stack into a head and tail. And in this case, I'm doing it wrong. So that's a bug. The correct code is actually returning the head. That's what it should do there. Oh, no, I'm sorry. I'm confusing myself. So in this case, I'm returning the head and saying the tail is the new state. So I'm sorry, there's a bug in that code. That toCaller should be head. My bad. I'm also have a function there that handles the push that just pushes the element on top of the stack. So sorry for making that so confusing. So let's just see that. There's an obvious bug in this stack. Maybe you're seeing it already, but if not, we'll just like show you what that is and show you what happens. So let's crash our stack. So I'm going to go into my editor now, and I'm going to font bump a good few times. How does that font size look? You want one more? Good? Okay. So the way we talk to our process, behind the scenes, we have a supervised stack process that's already started. And we can just like push things onto our stack by doing this, and it's sending messages to our stack process, and then we can pop things off. But we popped everything off our stack. What's going to happen now? You guys want to guess? Oh no, it blew up. But we can just push things onto our stack, and everything is hunky-dory. And that is because we have a supervisor that just like saw that there was a crash and just restarted our stack server process, and we can just like hum along and everything's hunky-dory. So that's supervised worker processes in action. So now I want to talk about Phoenix LiveView. Have people heard of Phoenix LiveView at all, or anybody? Okay, so not so many. So Phoenix LiveView is a subproject of Phoenix, which is the web application framework for Elixir. And Phoenix LiveView kind of pioneered a different way to do web application development. And what it specifically does is lets you write a server-rendered app that has the behavior and performance of a SPA like you would write in React. And the way that it does this is it is maintaining the state of every connected user on the server. It has a client library that sends events on user interaction up to the server, and it also receives state updates from the server. So basically, the page will behave completely dynamically, but you don't have to write any front-end code at all, which is really pretty awesome in practices. But what this means, like as an implementation detail, is you have a process on the server for every connected client of a system. And that could easily be millions if you have like a high-traffic web app, right? And because OTP is pretty awesome at handling that scenario, things continue to work. You can have millions of stateful WebSocket connections on a single box, and they've like tested this out. So let's see what this looks like in code really briefly. This is kind of like the hello world of Phoenix LiveView. It's a multi-user chat. And so this is the function that renders the HTML, and this gets called anytime the state changes, basically. And the state in this case is the list of messages, and we're just like looping over the messages and displaying them in a list. Right below it, we have a form. That phx-submit add message is basically saying when any user submits this form, we're going to have an add message that's going to bubble up to the server. An add message, or yeah, an add message event that's going to bubble up to the server. So what it looks like to handle on the back end that stuff is we have a mount function that sets up our initial state, which is an empty list. We have an add message function that gets called when, like I said, that form is submitted. And because we have a single process for every connected user, we need some way to like notify all the other processes when somebody's done a chat so that everybody sees it. And we do that by leveraging pub/sub that's built into Phoenix. So we're just broadcasting over a pub/sub channel. Here's a new message. Finally, we have a handle info that basically gets called when a message comes in over pub/sub, and at that time we just put it on the state, which is then going to trigger the re-render down on the client. So that's how everything fits together. And what it looks like in practice, we can just say like hi in one browser and say what's up in the other. And everything just works, and yeah. Okay, so now let's talk about Wasmex. So where am I at time-wise? Okay, not too bad. So Wasmex is the Elixir wrapper for Wasm time, and it's what lets you talk to WebAssembly from Elixir. It was started by a guy named Philip Tezenow in 2022, and behind the scenes it makes use of Rustler, which is a great library that makes it really easy to use Rust code from Elixir. And it also embraces the OTP model under the covers in that all of the WebAssembly modules and now components are started as managed Elixir processes, which has some pretty nice benefits, I think. The way that you communicate with those WebAssembly modules and components is via Elixir message passing, which we'll see here in a second. All right, so Wasmex here in the last just really few weeks has had a new release 0.10 that has added support for the component model. It has both a low-level API to talk to component functions and then a macro that's kind of like the equivalent of bindgen that will give you idiomatic Elixir functions to call WebAssembly component functions. It supports all of the Wasm types mapped onto their Elixir equivalent. It supports interfaces, and it also supports imports that are implemented in Elixir and then used by WebAssembly components. Under the covers, that is actually async message passing between different Elixir processes, but it's kind of like glossy. It's behind a synchronous veneer, essentially, so it appears synchronous from the calling side. The only thing that I haven't done yet, or one of the big things I guess I haven't done yet, is support resources. I think that's doable. I just kind of need to think a little bit more about how that should work and how it makes sense to work from the Elixir standpoint. All right, so the type mappings. The basic types, strings and numbers and floats and booleans and lists, they just have direct equivalents in Elixir, so that's pretty easy to figure out. Records, right now I'm mapping onto maps in Elixir. There's also a thing in Elixir called structs, which eventually I want to have a way to specify declaratively, like this record goes with this struct in Elixir. I haven't implemented that yet, but that's definitely a plan. Variants map pretty nicely onto a tuple in Elixir. I don't have it on the screen, but tuples also map directly into Elixir. Results, it's idiomatic in Elixir to have functions that return tuples that have either an OK or an error and then a value. And so I'm mapping results onto those kinds of tuples. Flags just become maps of Booleans. Enums map really nicely onto atoms, and options are just going to be a value or nil. All right, so let's see what it looks like to re-implement that chat that I just showed you as a WebAssembly component. The first thing that we need to do is define the WIT interface to our WebAssembly component that gives us what we need. And so we're just making a chat room world. We're going to import a publish message function so that we can send messages onto PubSub, which is provided from the outside world. And then we're going to export an init function that sets up our initial state, which is just going to be a list of those messages, which are strings. We're going to have an add message function, which gets called when the user submits the form. That's just going to take a message and return a result. And then finally, we have a message added function that's going to get called when a new message comes in over the PubSub. Its job is to take the message, the current state, which is a list of the current messages, and return a new state, which is a new list of messages. So that's the interface. This is an implementation in JavaScript of that WebAssembly component. It was pretty easy to do in JavaScript, and not much code is the reason I went with JavaScript. And so I'm importing publish message from my imports, and then I'm exporting an add message function which uses publish message. And in this case, I'm publishing the message that the user gave me, and then I'm also adding another message just so I can see that, yeah, this is actually the Wasm component version of the chat. I'm also, rather than starting with an empty list, I'm giving it an initial message so that you'll see that message when you join the component chat. And then finally, the message added function is pretty straightforward. It just takes the current message and the list of messages and just tacks on the message. So nothing much going on there in the message added. So this is what it looks like to consume or use our WebAssembly component in Elixir. We have a module, which is really just a namespace, and then that use statement is calling a macro in Elixir. And this is component server macro, takes the WIT, and it will actually produce idiomatic Elixir functions for all of the exports in the component for us. And then we also define our imports, which just maps published as message onto the published message function right below there. And that published message does the same thing we saw earlier. It's just sending the message to the PubSub. All right. This is what it looks like to use our chat server WebAssembly component in what's called a supervision tree, or in this case, it's an OTP application which has a supervision tree. The way that looks is we set up a list of children. I'm not showing you all of them, but the one here that we care about is our chat server. And we just give it a name so that we can find that process and be able to talk to it. We give it a path to the WebAssembly module, that's the Wasm file. And then we give it some WASI configuration. If we wanted to let our component do HTTP calls or things like that, it would go in that WASI P2 options structure there. Finally, we're telling it, our supervisor, how we want to supervise this process, and that one-for-one strategy just basically says, hey, if this chat server process crashes, please just restart it for me. But don't worry about any of my other children or anything else. All right, finally, we see here's what it looks like to rewrite our LiveView to basically delegating everything onto our WebAssembly component. We have that mount function we saw before, and now we're just going to, instead of returning an empty list, we're going to call our chat server. We give it the address of the process. That's what we saw, wasmio 2025.chatroom is kind of like, well, the name of the process. And we get back whatever it gives us, and we say, hey, this is the state. Our add message function is also just taking the message that the user typed in and just handing it to the WebAssembly component via the add message. So that's what it looks like. It's that add message function is not code that we wrote. That's basically where the macro looked at the WIT and dynamically produced that add message function. Finally, message added is getting the message and the current list of messages and just sticking it on there. So that's how everything fits together. Let's see what it looks like in practice. And to do that, over here, we'll go to Wasmex chat. And right away, we'll see that we have another message here. And if we talk, we'll see that we get an extra message over there. And we can chat back and forth, and everything just works. What? Sorry? Okay. All right. So that's cool and all that it works, but let's break it on purpose. And to do that, we're going to go into our code. And we're going to go to chat room, and we're going to do something dumb. We're going to define a secret word, and we're going to say, cursor's kind of wanting to help me here, and I'm going to let it. We're going to say, if you send a message that's a secret word, we're going to blow up on purpose. So, of course, in JavaScript, the secret word is wat. Everybody know where wat comes from? I saw at least one person. Nice. Okay. So we need to rebuild our WebAssembly module. And I have a shell script that's using JCO to do that. We need to, okay. Alrighty. We need to restart our server so that it will reload the WebAssembly module in the supervision tree. And we reload our browser to reconnect. And then things still work. But if we type the secret word, we'll see, oh man, something went wrong, and then it'll reconnect. Over here, it doesn't know anything happened at all. And everything is just fine. And so that is our supervisor managing our WebAssembly component for it, seeing that it crashed, and restarting it for us. All right. So, where are we going from here? So, Wasmex, at least the component support in Wasmex, is fairly new, and I definitely have a few things that I want to continue to add to the Wasmex component support. One of the things I want to do is implementing resources. Still got to think about how that should work with Elixir, because Elixir is not stateful by default, and so it's a little weird, but I think it'll work out pretty well. I definitely want to improve the config for capabilities. Like right now, there are things like you basically just turn HTTP off or on, and I'd like to be able to say, here's what you can actually call. I need to add support for pre-opens and file system things. But the main thing I need to do is get people using it to find out, what are the missing things and what works well and what doesn't. And then long-term, what I want to actually be able to do with Wasmex, and I'm starting to reach out to some Elixir SaaS platforms as well. I think the support for the ability to, on a SaaS platform written in Elixir, be able to use WebAssembly components for user-defined code, I think is a really compelling story. Every SaaS platform at some point needs to be able to extend and let users, have some control. And right now, that's like webhooks and API calls and kind of yucky. And I think WebAssembly Components is a great fit for that kind of thing. The other thing, I'm kind of interested in longer term, is I think LiveView is a really great way to build web applications, and being able to do that in a polyglot way using WebAssembly Components, I think, is a really interesting idea. And longer term, I'd love to build a project that would let you do that. So that's kind of what I have. And I think maybe I have like a few minutes, maybe, yeah, maybe like 4 minutes for questions or something like that. So, yeah, that's what I got. All right. Any questions?
What motivated you to do this work?
So I was really most interested in that, like extending SaaS platforms with Wasm components. Well, both of the bottom one as well, but I think that's the more imminently like practical thing. Elixir is a really great language for building SaaS platforms, large web applications. And yeah, the extension story for that is like kind of clunky. And I think using WebAssembly components from Elixir is going to serve a need there.
I guess it's kind of a comment and a question.
Sure.
Have you done much with like other languages than like Rust for using maybe, what languages have you like tried executing as a component inside of Wasmex?
Certainly Rust. I think we have some tests that use a Rust web component, I'm sure. I did an experiment with Python. That worked fine, although the components are huge because Python. So those are the three that I know I've tried and worked.
Yeah, I'm curious, it would be funny if you had like, because you can like do JavaScript too, and I guess like sell resiliency, but like let people still use JavaScript if they like using JavaScript. It would like be very loaded, but you could just like make your JavaScript a lot more resilient going through this convoluted.
Supervised JavaScript? Yeah, that could be a thing for sure. Yes.
I saw with the WebAssembly module, when you hooked it up to LiveView, you still had to write like the bindings to take the WebAssembly module and tie it to like the LiveView publish and subscribe and stuff. Is there ways that could be like smoothed out the experience with macros, or what do you envision?
100%. Yeah. Yeah, I wanted to have that code explicit in the demo just so we could understand what was going on. But yes, I think what you could do is just like replace all that code with a use component live view essentially, and say like mount maps onto this function, handle event maps onto this function, etc. Yeah, I think you could do that with a macro. I'm interested in like doing that. It would be more sort of a fun experiment, I think, initially. But yeah, I think you could 100% do that. It's great. Great question. All right. If there's nothing else, I'll give you your last minute back.